think I got the date wrong in the title. Today's May 11th. Let me change that. May 11th. There we go. Ooh. So yeah, good morning everyone. I hope you're doing okay. Hello. I'm just gonna wait for a few more people to show up before I get started. Good morning. Great weekend this weekend. Yeah. Yeah, did some Mother's Day stuff. Kind of a weird Mother's Day, just due to everything. But yeah, no, it was a good weekend. It's a good weekend. Hope you guys had a good weekend too. Oh, good morning. Yeah, we'll probably get started in about a minute or two. Yeah, any minute now. It's good to have a good stretch. Yeah, let's see. Okay, we got 10 people. Let's do this. Okay, we are going to continue our investigation of trigonometry today. So we're looking at the connection between triangles and circles. So that's what we're doing. It's going to be great. So I'm just going to do a quick little review from what we were doing last week. It's been a while. So what we did but on Friday, is we took a look at this circle and we looked at, okay, well, I could have an angle here in this first quadrant. Remember, this is quadrant 1, 2, 3, and then 4 finally. So those are the 4 quadrants that we have. So if I were to have an angle in the first quadrant, right, remember that this is our initial side here, which is essentially the x-axis, and the terminal angle right over here, right, the angle that we get is this angle right here, theta. Okay, so there's our angle theta. Now, if I were to have a slightly longer angle, like perhaps this angle right here, well, what we would do, so our angle still is this angle, but we have what we would call our reference angle, which is actually this angle right here. So we keep our reference angles, in line with the x-axis. Okay, and we'll see why we do that in just a minute. And then same with this angle. So if I have like a I think we call this a reflex angle if it's greater than 180 degrees, like that. Well, then our reference angle is just this smaller angle here, the angle between the x-axis and our terminal side. And same with this angle here, even though it's this huge angle that goes all the way around, it's all the way into the fourth quadrant. The reference angle is just this smaller angle here between the x-axis and the terminal angle. And we'll see why we do that, hopefully by the end of today's class. So, time to remind you about the trig ratios that we have. So let's talk a little bit about the trigonometric ratios. Trigonometric ratios. Okay, so we're going to take a look at how the trig ratios, I refer to them as trig ratios, but if you want to call them the trigonometric ratios, that's fine too. We're going to look at the trig ratios, and we're going to look at how they correspond with this here circle. Okay, it doesn't really seem like you could talk about trigonometry with respect to a circle, but it turns out that circle geometry is essential in your learning of trigonometry. So our trig ratios, let's just quickly review them. We have sine of theta, we have cos of theta, and we have tan of theta. Okay, so those are our three trigonometric ratios, and they have everything to do with a triangle, a right angle triangle. So here's our nice little right angle triangle. Okay, here's the right angle right there. Here is our angle theta. Okay, and with theta we have a few different sides. Well, we have three sides that are relative to our angle theta. So here's our angle theta, and the side right here at the bottom, this side right here, this side is adjacent to our side, right? So we call this the adjacent side because it is adjacent. Adjacent just means beside, right? This side is beside our angle. We have the opposite side, so here's our opposite side right here. So our opposite side is opposite to the angle, right? So here's our angle here, and it's opposite to the angle, right? They're on opposite ends of the triangle, right? They couldn't be further away from each other. And then everyone's favorite side, the longest side, it's always the longest side on a right angle triangle, is the hypotenuse. Hypotenuse. Okay, so here's our hypotenuse. So I'm gonna refer to these sides as A, O, and H. Okay, adjacent, opposite, and hypotenuse. And it's likely that you already remember this, but maybe not. Maybe not. Okay, so sine of theta is equal to, well, you may have remembered the old saying SOHCAHTOA. SOHCAHTOA. Okay, so sine of theta is opposite over hypotenuse. Okay, cos of theta is equal to adjacent over hypotenuse. Okay, and tan of theta is equal to opposite over adjacent. Okay, so maybe I'll space these out a little bit more so we have just a little more room between them. There we go, that's better. Okay, so those are our three trig ratios. Fantastic. So let's talk about how these correspond to the circle over here. Okay. I guess are there any questions here? Have we seen this stuff before? I'm fairly certain that you would have seen this before. I think we usually introduce this stuff in grade 9. So you should be vaguely familiar with what sine, cos, and tan are, and some things like that. So I guess one more thing too that I want to remind everyone is the Pythagorean theorem is well used here. So the Pythagorean theorem is useful here because we have a direct relationship between these three sides. So remember that the Pythagorean theorem says that a squared plus b squared is equal to c squared. Well, here a could be our adjacent side, b could be our opposite side, and c would be our hypotenuse, right? So the Pythagorean theorem says that the hypotenuse is equal to the square root of the opposite side squared plus the adjacent side squared. So this fact is going to come in handy in just a minute, okay? So we've got the Pythagorean theorem, we've got sine, cos, and tan, and SOHCAHTOA. We've got opposite, adjacent, hypotenuse sides, and we've got a circle. And our next goal is to put all of these together into one nice little package, okay? And this is effectively the essence of trigonometry. Okay, so let's see here. Where am I going with this? So let's talk a little bit about this first quadrant, okay? Let's investigate the first quadrant. The first, oops, not FERT. First, with an S, quadrant. Quadrant. Okay, so I want to talk a little bit about the first quadrant here, okay? And I'm going to draw the X and Y axis, okay? And, oh, I wonder if the geometry thing will let me do a nice little quarter of a circle. Come on. No, come on. Let me do a nice little quarter of a circle. No. Okay, what I'm going to do is I'm going to quickly just draw a circle. Nope. There we go. And I'm going to move it. It'll do like a full circle, but not a quarter of a circle. There we go. And then what I'll do is I'll erase it and just portions of it because I don't want the whole thing. I just want part of it. There we go. Okay, so here's my first quadrant. And let's talk a little bit about how sine, cos, and tan can be used here. Okay, so I've got let's see, I'll go in green now. So let's say I've got an angle here, and our angle is going to have these coordinates here. Okay, so here is my triangle. Oops. So there's my triangle right here, like this. Okay, and it's a right angle triangle. I just want to make it look really nice so that our diagram makes perfect sense and we're able to read it very, very clearly. Okay, so here is our triangle. It's a right angle triangle. Here is our angle theta. Okay, so there's our angle theta. This side right here is the radius of the circle, right? So we've got the radius of this circle. And this point right here is the point x, comma, y, right? It's because we're on our Cartesian plane, and this point right here is going to turn out to be extremely important to us. So this point right here that I just outlined in pink is a very important point with respect to this angle. Okay, so I've got this circle, right? I've got the circle centered at the radius, or sorry, centered at the origin. The circle has a radius r, so here's my radius r. And when I write this angle, okay, I've got a nice little right angle here, a right angle triangle. So when I place this angle onto this circle, then I have a nice little right angle triangle. And this is where trigonometry fits into the circle geometry. Okay, so this point x, y, we can actually figure out exactly what those coordinates are, and I'll show you how in just a second. So let's just remind ourselves of a couple of things. So this side right here, this is the adjacent side. This is adjacent. This is our adjacent side. And this right here, that right there is our opposite side. Okay, and our radius is actually our hypotenuse. So let me actually just move this over for a second. So r, and I'm going to write r is equal to hypotenuse. Okay, so the radius of our circle happens to be equal to the hypotenuse. Okay, isn't that cool? So another thing too is that our adjacent side is equal to x. right? So, and I'm talking about this x right here, right? Because the x coordinate is talking about how far left and right our point is. Well, this point goes all the way down, right? So this point right here is our x value. So this is actually equal to x. And for the same reason, our opposite side is equal to y. Okay, they have exactly the same meaning. Okay, so maybe you can start to see where this is going. So this point x comma y, well, we have some nice little relationships going on right now. So let's talk about what these relationships are. So let's talk about how sine theta fits in here. So sine theta, that's equal to opposite over hypotenuse. So opposite over hypotenuse. Okay, and the opposite side we're saying is actually equal to y, and the hypotenuse is equal to r. Isn't that funny? So this sine theta is equal to y over r. Additionally, we have cos of theta. Cos of theta is equal to the adjacent side over hypotenuse, and that's equal to x over r for the same reason. And then finally tan theta. Tan theta is equal to opposite over adjacent, which is equal to, the opposite side is y, so we've got y over x. Isn't that funny? Isn't that funny? So I'm going to just throw a couple more things in here. Just a couple more things in here. Let's see here. Okay, so I guess what I want to do, just as a little sanity check, I think what I want to do next is just throw in a quick question for you, just to see if you're able to keep up. So what I'm going to do is I'm going to throw a question into I'm going to give you a question. I'm going to give you a couple minutes to solve it because I want to just make sure that we're following along. So here is my question. So if r is equal to 2, okay, I want you to find the coordinates so that is like, tell me what x and y is. Find the coordinates x, y of the terminal point and by terminal point I'm talking about this thing, the terminal point of, let's say, 30 degrees. Okay? So yeah, just to clarify, the terminal point is the like, you know, here's my initial side. My terminal side is going to be right over here. So at 30 degrees, it's going to look something like this. The terminal point is going to be right here, and the radius here is equal to 2. So the radius is equal to 2. I've got my terminal side, which is 3. I want to know what are my x and y coordinates of this side. And you can use all these equations if you want, or you could just use basic trigonometry. In fact, you technically don't need trigonometry. You could derive this from scratch if you wanted to. But I want you to try that. I want to give you 2 minutes just to see if we're able to sort of keep up with this. So I'll give you 2 minutes. You know what? This one might actually take 3 minutes. I'm going to give you 3 minutes starting now. So see if you can find those x, y coordinates of the terminal point of 30 degrees. By the way, you may have to use a calculator to find sine and cos of 30 degrees. Okie dokie. Let's take a look at this. So just a couple of things. Now I know that it may have been a while since you've taken a sine function, or you've evaluated a sine function or cos function or any kind of trig function. So one thing to remember, sine of theta, sine of any angle, or cos of any angle, or tan, or any kind of one of these angles, is for our calculator. Okay? Now, when you get to either grade 11 or grade 12, depending on if you continue on with the advanced placement program, you will actually need to memorize several trig ratios. You don't need to do that right now. We're just going to always use our calculator for this type of work. Now, one important thing is to make sure that your calculator is in the degrees mode, because right now we use degrees. In grade 12, maybe grade 11, you will be using something called radians. I'm not going to bother telling you what radians are. The closest analogy is, it's like the difference between miles and kilometers. Right now we're using miles. You can think of miles as being, well, I mean, at least in maybe the United States, miles is kind of like more like the classical, kind of everyone kind of knows what a mile is. I mean, I think a lot of us actually prefer feet and inches. When, like, if I asked you how tall you are, probably know how tall you are in feet and inches. It's what is, I'm pretty sure, what's on our driver's license. But not many of you would know how tall you are in centimeters, right? So, but I think that we can all recognize that, the metric system, meters, centimeters, it's a superior system, but we're a little more familiar with how feet and inches work, even though it's not that good. So degrees, it's the same kind of thing. Everyone knows what a degree is, right? You got a 360 degrees, 180 degrees, like we all know what that means, 90 degrees. Radians is a more of a mathematical interpretation of what a angle is, and it turns out that with a radian, you have 2 pi radians in a full circle. So that's how that works, and it has everything to do with the circumference of a circle. So we use it in terms of multiples of pi, or fractional multiples of pi. So like 180 degrees would be pi radians. 90 degrees would be pi over 2, or half of pi of a radian. Anyway, we're not talking about radians today. We're going to be using degrees. So one thing you have to make sure is that on your calculator, it is in degrees mode. So I'm just going to show you where the degree button is on my calculator. So here is mine, and you can kind of see right over here, it says, might be hard to read that, but it does say degree, D-E-G. So we need to make sure that our calculator is on the degrees mode. So the way I've done that is, boy, how do I do that? I think mode? No. I should have double checked this ahead of time. I mean, oh yeah, here it is. So my button has a, no, that's the DRG. That's different. Oh yeah, no, that's it. Okay, so degrees, radians, and gradient. So my calculator here has this DRG button. You can see how old my calculator is by how worn that button is. So anytime I press that, it changes it from degrees. Well, right now it's actually on radians. Not sure how well you can see that. There's gradient and degrees. You know what I'm actually going to do is I am going to switch this up. Oops. Here. Gonna make myself nice and small, and then I will use the camera on my iPad because it's a much clearer camera. Okay, and I'll just do this. Boom, boom. Aha, there we go. So don't mind my gnarly desktop. There we go. Okay, and then where's my calculator? Okay, here it is. Okay, this is much better. Okay. Oh yeah, look at all that clarity you have. You can see all the gross dust on my calculator now. High definition. Okay, so here is here's the degree button on my calculator, and it goes back from degrees to radians to gradient. So we just need to make sure that our calculator is on degrees, and on your calculator there should be some kind of indication on the LCD display panel that you are using degrees and not radians. One little pro tip that I can give you, if I can just find it, if you get some kind of like a mechanical pencil or a sharp pencil like this. Where's my lens? There it is. Like this. And if, like, let's say that it's on radians and you can't find that button, what you can do, there it is. There's my, see, it really is my calculator, is you can hit reset. So you can kind of press this button. 99% of calculators have a reset button, and as a standard we use degrees. So by default your calculator will come with degrees. So if you can't find that button, and if maybe your calculator was turned on in your backpack and then a whole bunch of buttons were pressed and the mode is all weird and it's just acting all weird, sometimes they'll give you like some kind of weird floating point, like precision error. So even if you write in 1, it'll write like 1.000000, and it'll just fill the screen with zeros. It's kind of annoying. If you don't know how to reset that, just hit this reset button, and then it will go back to the default setting, which is degrees. So if you can't find that setting, just reset it. Do a little hard reset, and that should fix your problem. So now that we're on degrees, let's see if we can get to the bottom of this. I wonder if I can do this. Oops, what the heck? What did I do? Oh yeah, I'm in GoodNotes. Okay, get rid of that. I'm gonna see if I can. Okay, here's my camera. I wonder if I can split screen this. Oh, okay. Okay, here's what I'm gonna do. Nope, that's not what I wanted. I wanted the camera. Can I do a camera? No, I thought that maybe I could do a camera like sort of split screen. No, it doesn't want to do that. No, okay, whatever. Good enough. Okay, so what we're gonna do now is, where did my case go? Here it is. Let's actually go ahead and solve this problem. So we need to be using our calculator for the sine and cos portion of this problem. And here's my pencil. Okay, so sine and cos. Let's, the heck? Okay, here we go. So I want the xy coordinates of this terminal point. Well, basically what I'm going to do is I'm going to be solving for y, I'm going to be solving for x in these two equations. So I know that theta is equal to 30 degrees and r is equal to 2. Okay? So I know that, let's say, what is it? Sine of theta is equal to, what was it, x over r? I think it was x over r. X over r. Well, that means that r sine theta is equal to x. There we go. And so we can solve for x now. So sine of theta, or sine of 30, so this is equal to 2 times sine of 30. I happen to know that sine of 30 is equal to a half, but I'll just double check. So sine, I'm going to show you how I do this on my calculator. It's probably very similar to your calculator, but I'll just sort of walk you through it. So sine of 30 is equal to 0.5. So that's how it looks. Boy, my calculator looks really dirty on camera. In real life, I swear, it doesn't look that dirty in real life. Just the light is just picking up all that dust. It looks really gross. Anyway, Sine of 30 is equal to 0.5, so we can just use that right in our equation. But remember, we had to multiply sine of 30 by 2. This is sine of 30 times 2, so I'll write answer times 2 equals 1. And we probably could have done that in our head. That's fine. So this is equal to 1. Oops. X, in this case, is equal to 1. Okay, what about the one? We had cos of theta is equal to y over r. So that means that r times, cos of theta is equal to y. So now we'll just solve this. We've got 2 times cos of 30, and that's equal to y. So again, let's punch this in. There we go, camera. Okay, so cos of 30. There we go, cos of 30. So here's my cos button. So cos of 30 equals, so it's 0.8660254 blah 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 blah. So some crazy long irrational number, and then I'm going to multiply that by 2 times 2. 1.7320. Okay, let's do 3 decimal places. So 1.732. 1.732 equal, come on, 1.732 equals, and I'll just write it in here, 1.732. So the coordinates, and I'll put a little, I should actually put a little dot on top of this because we rounded. Okay, so the coordinates are 1 and 1.732. Very cool. Okay, so those are the coordinates. So if you got the same thing, x equals 1 point and y. Yeah. Okay, someone's paying attention. Aha, thank you. 2 people are paying attention. Okay, maybe 3 people are paying attention. That makes me so happy. It's great being a math teacher for so many reasons, because when you're wrong, it's actually good. Like, when a student is wrong, you know, it's like, okay, now I got to fix the problem, blah, 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 blah. When a teacher's wrong, then and all the students kind of correct the teacher, then that's a happy accident as far as I'm concerned. So yes, I got my formulas mixed up. So it goes to show that even after decades of experience, you still make these silly mistakes. So I'll just switch these out, y and x. So this should be x and y and x. So in this case, this is what x is, and this is what y is. Okay, so I got these mixed up, and I'll just do this and 1. Beauty. Thank you, folks. I'm so happy that you guys are paying attention. It's really hard as a teacher, especially with this distance thing. I can't see you guys work, right? So sometimes I just kind of have to hope that you guys are actually trying the problems that I'm giving you. But that's proof that you guys are. So that makes me very happy. Okay, great. So let's see here. Okay, so I'm gonna go through one more sort of concept here, and I know that this is one of the more abstract topics in this class, is trigonometry, because although there's lots and lots and lots of applications of trigonometry, and it's one of the most applied areas in all of math, we do have to be a little bit careful here, because the units, what I'm trying to get at is this thing called the unit circle, and the unit circle, it just adds an extra layer of abstraction, so it's a little more abstract. But the thing is it's a really strong tool. So it's a tool that we use in trigonometry, and the tool takes a long time to wrap your head around. So what I'm trying to do here is I'm trying to just slowly introduce it to you over the course of a couple of classes. So we're kind of taking some baby steps there. So what I want to talk about right now And it sounds like I might be kind of going all over the place, and that's because I am, but there's a lot of concepts that we're trying to pack into one here. So I just want to make sure that we've got all the pieces of the puzzle ready to go, and then I think by next class we'll be able to put it all together. Okay? So this last piece is on similar triangles, and I know that we are good at similar triangles, because if we scroll up to the very, very first slide, I'm always reminded of this slide because it's the thumbnail for this little booklet that I've made for your class. Here's similar triangles right here. Is the very first thing that is in this book. I don't think this is the first thing that we did together in class. It's just the first thing that I put in this digital notebook. So we've got these similar triangles. So I'm going to go back here all the way to the end, and I'm going to just do a quick recap of similar triangles, and then I think we're going to call it a day. I'll make it a nice easy exit slip for us today. So similar triangles. Similar triangles. Okay, so when two triangles share all three angles, when two triangles share all three angles, we say they are similar. Okay? When they're similar, all of their sides are proportional. Okay? All the sides are proportional, which means that the ratio between each of the sides is going to be the same. So to give you just a quick little example, so here's one triangle, here's another triangle. Let's say that this side is the same as this side. Let's say that this side is the same as this side. Or I'm calling them sides. I'm meaning to say angle. The first angle is the same as okay, let me say that again. This angle is the same as this angle is the same as this angle, and finally, this angle, 1, 2, 3, is the same as this angle, 1, 2, 3. Okay, so I've got these two angles, there's these two triangles, and let's say I've got this side here, which is A, and this side here, which is capital A. This is lowercase b, capital B, lowercase c, capital C. That means that a over little b is equal to big A over big B, and in the same sort of respect, we could say that A over big A is the same as B over big B, right? So we have all these nice little relationships that we're going to use. So we're going to be using this fact of similar triangles to talk about this kind of interpretation of trigonometry. So we're building up our understanding of something that is called the unit circle, and this is a really important topic in the field of trigonometry. So like I said, it's a little more of an abstract interpretation of trigonometry. It's harder to think of this in terms of the real world. It seems to be kind of like a like I said, like a very abstract topic. And it's because it is abstract, but we're trying to build up to give ourselves a tool that we can use for more abstract mathematics. So I hope that wasn't too confusing. We're gonna carry on with this tomorrow. I think that tomorrow we're actually going to be able to define what the unit circle is and how it works with trigonometry. So anyway, for the exit slip today, exit slip. I want you to calculate sine of I don't know, let's say 270 degrees. Okay, that's it. Just punch that into your calculator, tell me what you get. Okay. Oh yes, our project. Yes. Okay, I'm glad you reminded me. So I think I've pretty much decided what we're gonna do a project. Yeah. So as for the project, I would like to put together a package for you, like a little document for you to read, that just kind of outlines the expectations of the project. Thank you for reminding me to talk about this, because it completely totally slipped my mind. So as for the scope of the project, I don't want to say it in a video, because I don't want you to have to keep referring to the video. So I will say this, that sometime this week I'm going to post a document on Google Classroom, and that document will be the outline of your project. So I'm not going to tell you what your project is going to be. That's going to be kind of your choice. There's going to be a lot of sort of self-led, interest-based decision making with regards to the subject of your project. But I would like you to follow some of the guidelines. I'd also like to talk a little bit about the the rubric, how I'm going to mark it, and that kind of thing. So stay tuned. That will be on Google Classroom by the end of the week. I'm probably going to have a very similar type of project for my other classes. So I'm trying to sort of put together a document that will cover all of my classes. But there will be some unique aspects of the project for you. For this grade 10 advanced class. It'll be different than my other classes, but I want the sort of the process to look similar to my other classes. So anyway, yeah, stay tuned for that. And if you have any questions or suggestions, like if you are really itching for a certain thing to be a part of the project, don't ever hesitate to let me know. I'm always interested to hear about what my students think about project ideas and things like that. So yeah, don't be a stranger. Yeah, so I'm gonna go, and I'll talk to you guys tomorrow. So we'll be on at the same time tomorrow. And until then, have a good day, and stay tuned about the project. Okay, take care. Bye bye.